So in this video, I'm going to be teaching you how to find the general solution of a second order differential equation. Now, this isn't all the same, it's constant coefficient, but if you look, it's not just 0 on the right hand side. This adds an extra step where you have to find a particular solution and use the method of undetermined coefficients. I'm going to talk you through. But first, we have to find the complementary function. You find this by setting this term equal to 0 and finding the solution of the resulting equation. So we're going to find the solution of this. But you know this already from what I've covered, so I'm just going to do this quickly without the sound. And then now we've got the complementary function of yc equals, now if you notice by this t here, the independent variable instead of x is going to be t. So pay attention to that sort of thing in questions that you might be answering. So equals c e to the 6t plus d e to the minus 2t. Now let's find the particular solution. So the method of undetermined coefficient, we're going to substitute a solution of this form into this equation and see what happens, basically. So I'm going to be substituting a solution, I'm going to be putting a trial solution, the form y, you can write yp equals or y equals, doesn't really matter, I was never sure about the notation, but it makes no difference. P e to the 5t. Now it's going to be substituted in here. Okay, so now we're going to substitute this in, so we know y prime is 5p e to the 5t. Now just to note, if this has terms, for example, if this had an e to the 5t in it, there was like e to the 5t here and these for the same term, it won't work. And I'll do another video maybe in the next few days explaining why that is and what you do in that case, but bear with me now. So y double prime equals 25p e to the 5t. Okay, so here, so 25p to the 5t minus 4 times 5p, well that's 20p e to the 5t minus 12p e to the 5t equals 3e to the 5t. Now you can just take all the coefficients of e to the 5t or divide through by e to the 5t, however you want to think about it, because e to the 5t is never 0, so we're allowed to do that. So these can all be cancelled. And there's just quite a simple equation now. 25 minus 20 minus 12, that's just 5 minus 12 or minus 7. So minus 7p equals 3. Let me just check that's right. Yeah. So p is minus 3 over 7. Okay. So now we're going to substitute back in, so I know that my particular solution yp, and this p, that could be a q or whatever, it would still be called yp for y particular solution, is going to be minus 3 over 7 e to the 5t with no arbitrary constants. Pay attention to that. So now all we have to do is write down the general solution, which is yc plus yp. Now, I don't really have any room left, so I know it's a bit naughty and you'd never do this in an exam or in a homework answer. I'm just going to write it here. So y equals c e to the 6t plus d e to the minus 2t minus 3 over 7 e to the 5t. Okay, there you go. Okay. So that's the general solution. You can always substitute back into check, but it's often easier just to substitute the particular solution in back to check, because that's where you're most likely to go wrong. So that was how to find the general solution of a second order differential equation.